Hi students, in this video we're going to consider what's known as the ambiguous case of the sine rule. Right, so after watching this video you should be able to understand that some information in a triangle might actually mean there are two possible ways of drawing that triangle. We'll go through that at the very start. Recognize that these triangles are either acute or obtuse angled. Once again we'll look at that at the very start, and then in our worked example we'll look at how to use the sine rule to calculate unknown obtuse angles, not just unknown acute angles. The only thing we have to recall here, students, is the sine rule. And in particular, since we're calculating angles, we're going to use the form of the sine rule where the angles are in the numerator. Once again, just because it makes it that bit easier to rearrange. All right, so there are some occasions where there are two possible triangles that can be drawn. This usually happens when the shortest known side, so in this case the 7 centimeter side, is opposite the known angle. So the 7 centimeter side can go down to the right, or, as in case 2, the 7 centimeter side can go down to the left. And what that means is that there are two possible triangles that can be drawn, and hence there are two possible angles that could be calculated, or that should be able to be calculated, using the sine rule. So in this situation, I'm going to use theta A to call that the acute angle, and theta O to be called the obtuse angle. Now, because of this ambiguity, because we don't know which triangle we're looking at, or because the formula itself, the sine rule, can't tell which angle we're looking at, there are two possible answers, which is why using a diagram or knowing some context is important to know which angle we need, whether obtuse or acute. And that's why it's called the ambiguous, or the not clear case of the sine rule. Now, considering the previous example, the size of the obtuse angle can be calculated once we know the acute angle. So we can calculate this acute angle here using the sine rule. We've done an example of that already. But then how do we calculate this obtuse angle here? Now, looking at our diagram, this right-hand triangle here, made up of the two 7 centimeter sides, that's isosceles. So that must mean that this angle here must also be equal to theta A. That must also be the same value as our acute angle here. Looking then at this angle on a line, our obtuse angle plus our acute angle must equal 180 degrees because they both lie together on a line. They're supplementary. So our obtuse angle, in the ambiguous case of the sine rule, if we need an obtuse angle, we can just take the number that we get from using the sine rule, that angle, and subtract it from 180. And that will give us the obtuse angle that we need if we are looking to calculate an obtuse angle using the sine rule. All right, so let's put this into practice. We've got an obtuse angle down here. Again, it's just the example we've been dealing with. We've got our 12 centimeters and our unknown, and we've also got our 23 and our opposite side of 7 centimeters. So we can use the sine rule there. So sine theta over 12 centimeters is going to be equal to sine 23 over 7 centimeters. Rearranging that, sine theta equals 12, so multiplying by 12 gets it to the numerator. 12 sine 23 degrees over 7 is our sine theta value, so theta must be the inverse sine of 12 sine 23 over 7, which equals 42.05 degrees. But looking at our diagram, our angle is obtuse, so that angle can't be right. What the sine rule has just worked out for us is if that side's 7 centimeters, it's worked out that angle there. So to get our obtuse angle, we can just use the rule we developed on that last page. Our obtuse angle will be 180 minus 42.05 degrees, which gives us 137.95 degrees. So this angle in here is going to be 137.95 degrees. And that's how we use supplementary angles and the ambiguous case of the sine rule to help us work out obtuse angles. So after watching this video, you should be able to understand that there's some situations where the information provided might mean there are two possible triangles that can be drawn, one with an acute angle and one with an obtuse angle. And then recognize those two different types of angles and then use the sine rule and that 180 minus our acute angle to find out the value of our obtuse angle, if that's what you need to find.